Scientists from a European space agency have made a major breakthrough in understanding the path of the mysterious interstellar object known as 3I/Atlas, significantly improving humanity's ability to observe and study it as it prepares to leave the solar system forever. This rare visitor, only the third confirmed interstellar object ever detected passing through our cosmic neighborhood, has captivated astronomers since its discovery due to both its extraordinary origin and its unusual behavior. First detected in early July, 3I/Atlas was observed hurtling toward the Sun at an astonishing speed of more than 130,000 miles per hour, a velocity that immediately signaled it did not originate from within our solar system. Instead, calculations suggest it was likely ejected from a distant star system in the outer frontier regions of the Milky Way galaxy, potentially as long as 7 billion years ago. For scientists, this makes 3I/Atlas not just a comet, but a priceless natural time capsule carrying information about planetary formation processes far beyond our own stellar neighborhood. What has now transformed scientific understanding of this object is data gathered during its recent flyby of Mars. On October 3rd, 3I/Atlas passed within about 18.6 million miles, or roughly 30 million kilometers, of the red planet. While this distance might sound vast by everyday standards, in astronomical terms it represented a valuable opportunity. During this encounter, ESA's ExoMars Trace Gas Orbiter was able to capture highly detailed images and tracking data of the comet as it streaked inward toward the Sun. These observations provided an exceptionally precise snapshot of the object's position and velocity at a critical point in its journey. By incorporating this information into their models, ESA scientists were able to refine predictions of the comet's trajectory with remarkable success, achieving a tenfold reduction in uncertainty compared to earlier estimates. This improvement was far greater than researchers initially expected. When scientists first planned to analyze the Mars flyby data, they anticipated only a modest enhancement in trajectory accuracy. Instead, the results exceeded expectations, allowing astronomers to pinpoint the comet's future path with unprecedented precision. Reducing uncertainty by such a large factor is crucial when tracking fast-moving objects over vast distances, especially ones that are faint and rapidly receding from view. With the improved trajectory, astronomers can now aim their telescopes with much greater confidence, maximizing the scientific return during the limited window in which 3I/Atlas remains observable. The timing of this breakthrough is particularly important because 3I/Atlas has already experienced a dramatic and eventful journey through the inner solar system. After reaching its closest point to the Sun on October 29th, the comet temporarily disappeared from Earth's view as it passed behind the Sun's far side. When it re-emerged, astronomers noticed several unexpected changes. The comet underwent a sudden brightening event. They anticipated only a modest enhancement in trajectory accuracy. Instead, the results exceeded expectations, allowing astronomers to pinpoint the comet's future path with unprecedented precision. Reducing uncertainty by such a large factor is crucial when tracking fast-moving objects over vast distances, especially ones that are faint and rapidly receding from view. With improved trajectory, astronomers can now aim their telescopes with much greater confidence, maximizing the scientific return during the limited window in which 3I/Atlas remains observable. The timing of this breakthrough is particularly important because 3I/Atlas has already experienced a dramatic and eventful journey through the inner solar system. After reaching its closest point to the Sun on October 29th, the comet temporarily disappeared from Earth's view as it passed behind the Sun's far side. When it re-emerged, astronomers noticed several unexpected changes. The comet underwent a sudden brightening event, briefly becoming more luminous than models had predicted. It also showed a temporary change in color, suggesting alterations in the composition or structure of material being released from its surface. Most intriguingly, its tail briefly vanished, only to later reappear, adding yet another layer of mystery to its already unusual behavior. These strange characteristics have fueled intense scientific debate. Observations revealed that 3I/Atlas has a highly irradiated surface, likely the result of spending billions of years exposed to cosmic radiation in interstellar space before entering our solar system. Unlike comets that form closer to their parent stars and remain shielded within planetary systems, interstellar objects endure a harsh environment that can significantly alter their physical and chemical properties. One particularly puzzling feature observed in 3I/Atlas is its so-called anti-tail, a structure that appears to point toward the sun rather than away from it. While such features can sometimes be explained by viewing geometry and dust particle behavior, their presence in an interstellar comet has raised fascinating questions about how these objects evolve over time. Unsurprisingly, the comet's oddities have also sparked speculation beyond the scientific community. Some have suggested, without credible evidence, that 3I/Atlas could be an artificial object or even an alien spacecraft. However, the vast majority of astronomers strongly reject these claims, emphasizing that all observed properties of the comet can be explained through natural processes. Still, the fact that such rumors arise highlights how rare and intriguing interstellar visitors are and how much they capture the public imagination. From a scientific perspective, the refined trajectory provided by ESA's Mars flyby data represents a turning point. As 3I/Atlas begins its one-way journey out of the solar system, it will steadily grow fainter and more difficult to observe. Having an accurate prediction of its path allows observatories around the world to coordinate follow-up observations, making the most of the remaining months during which the comet can be studied. Researchers hope to analyze its composition in greater detail, searching for clues about the conditions in the distant star system where it formed. By comparing these findings with data from the first two known interstellar visitors, scientists can begin to identify patterns and differences that shed light on the diversity of planetary systems throughout the galaxy. The success of this effort also demonstrates the growing importance of planetary spacecraft in studying transient cosmic events. Missions like the ExoMars Trace Gas Orbiter are primarily designed to investigate Mars, yet their instruments can play a crucial role in observing objects far beyond their original mission goals. This kind of opportunistic science highlights how interconnected modern space exploration has become, with data from one mission contributing to discoveries in entirely different fields of astronomy. Ultimately, 3I/Atlas offers a rare glimpse into the broader Milky Way, carrying with it the history of another star system across incomprehensible distances and timescales. The tenfold improvement in trajectory accuracy achieved by ESA scientists is more than a technical achievement. It is a gateway to deeper understanding. As the comet recedes into interstellar space, the knowledge gained from its brief visit will remain, helping scientists refine their models, improve detection strategies for future interstellar objects, and better understand the processes that shape planets and comets across the galaxy. In this way, even as 3I/Atlas disappears from view, its scientific legacy will continue to illuminate humanity's place in the vast cosmic landscape.